Welcome back, everybody. This is Discovery Curiosity. My name is Dan, and today we are talking about programming in robotics. We're going to talk about what a program is, the different types of languages used in robotics, the softwares that are needed to write these programs, how we get the programs into the robot. Once we get it in the robot, how the program actually makes a robot work. So if you're as curious as I am, stick around and let's get started. All right, who's ready for programming? I am. So what is a program script? A program is a set of coded commands or instructions that tell an electrical and mechanical system what tasks to perform. So let's jump on the computer and take a look at what a program looks like, as well as some of the software that will be needed to actually write these programs. Alright, so we're going to take a look at some of the programming scripts for robotics. So the first one I have up here is Arduino. Arduino also has its own control module, which is nice because they're cheap, they're easy to get. They have a ton of different components you could use with them, so it's a very popular starting point for your DIY robotics. Another programming software is PyCharm. So PyCharm is just one of the many different interfaces that you could use to write scripts for Python. Python is a programming language, just like Arduino is a programming language. So they all have the same outcome, but they do it in different ways. Another one would be C++. So we have C++, Python, Arduino, and another one is MATLAB. So MATLAB is, I would say, almost a completely different type of programming software. It's more math-based. It's a little bit harder to learn, just because it does use so much math. But the nice thing about it is like the Simulink. So we can actually write these programs out in a visual type of format, and it kind of makes things a little easier to understand. But being able to see it and see the path it takes through these arrows, it really helps out on actual understanding what the program is doing. So let's go back to Arduino. So I have pulled up here, this is a programming script for a basic obstacle avoidance robotic car. So let's kind of walk through the basics of what a programming script is, highlight what some of these script lines mean, and how robots kind of work on a loop type system. Now I'm not going to go through a whole tutorial on how to write out these programs. There are many tutorials on YouTube that are great. It's not an overnight learning. It's not a 15-minute learn how to program. It's like learning a different language. It takes time. It could take months or even years to actually learn how to do this without walking through a tutorial. So I want to give you a basic understanding to be able to look at these codes and kind of understand what they're trying to say or what they're trying to do, to give you a better idea of how they actually work within the robots to make them move and to make them in a way autonomous. So pretty much what we have here is we're setting up in this first section all the basics for what our control unit needs to know about where our components are, what their limits are, where to send the data, and where to send that data when we send out instructions. But the main thing I want to talk about is the loops. So most robots work on a loop type system, and on this one what we are doing here is an if or else loop. And our first line says if the distance is less than or equal to 15 millimeters. So we're saying if we're about to hit something, we're going to tell it to stop, move backwards, stop, and then we're going to ask it here, look left and look right. So we're going to turn our sensor to look left and right, and we're going to take distance measurements. And then we're saying if that distance right is greater than or equal to the distance left, we're going to turn right. But if this is not a true statement, we'll go to the else part and we're going to turn left. And the reason we do this is because we always want the robot to be moving in the most efficient path, and that would be the path that it has the most room to move. So, and then it goes on from there. We have to tell it what happens if it looks both ways and they're both the same. What happens if it can't move anymore? So we keep going in this loop, and we have to put in a solution for every problem we could think that the robot can get in. And if we try and get all of them written down, and we get to the point to where we still can't get outside of this loop, then we have to put a fail-safe that says the stop and shut off. So that's the basics on how a loop works within a programming script, and I'm going to go into it a little bit after this in a more visual way and kind of explain to you on how the loop works visually, and it might kind of clear things up a little bit for you. So let's go ahead and jump right to that. Alright, so let's talk a little bit about how a program makes a robot move. So for this instance, we're going to assume that we have a simple robot, one that we only want to move forward and not run into any objects. The more complex you make a robot, the more tasks you want to do, the more complex the coding gets, and then the more sensors, the more data you're going to need to process. It just makes it more complicated. So we're going to say that we are going to have one sensor, which is going to be an ultrasonic sensor, and we don't want our robot to get within 2 feet of any object moving forward. So our first thing is we will have a sensor. So this sensor is going to provide data in the form of a measurement. So that data goes to the control unit. So the control unit has a program that we wrote in the terms that we want it to follow. And for this instance, since we only want to move forward and not run into any objects, we will run a simple loop. So this loop will constantly go around, and it gets to a point and it says, are we less than 2 feet? So once we enter this loop, it stops, it says, hey sensor. Sensor goes, yeah. Are we within 2 feet of anything? And the sensor goes, nah, we're good. So we keep on going. And it constantly does this until we get to a point to where we're less than 2 feet of an object. So what happens when we get less than 2 feet? So once we get around our loop to a point, it asks, hey sensor, are we less than 2 feet from anything? It says, yeah. Matter of fact, we are. At this point, we will branch off into another form of a loop. So this loop is more of a branch type. So we're actually asking the robot to perform 2 things. From those 2 things, we're going to make a decision on what we need to do. Every time we get to where we are within 2 feet of something, we're going to stop, we're going to back up, and then we're going to ask it to do something. So we're going to ask our sensor to move left and then move right. And why are we going to do this? Well, we want to know which direction gives us the most room to move. And from there, we get 2 sets of data. We get a measurement here and a measurement here. So we're taking a measurement from the left and a measurement on the right. Let's say we look left and we get 5 feet. That's a lot of room. And then we look right and we get 8 feet. So after receiving this data set, we know that 8 feet is definitely greater than 5 feet. And in our program, it's going to say take the greater distance, which is right. So we come down here, we X this one out because we don't want to go that way. So our robot's going to back up, turn to the right, and then go right back into our infinite loop. And it's going to keep going. Obviously, we're 8 feet here. We can do the math. We're going to end up moving 6 feet before we go through this process again. And it's going to constantly do this. Well, what happens if we run into a situation to where we're moving along just fine? Our loop says, hey, sensor, are we within 2 feet of anything? It says, yeah, we are. So it stops, backs up, turns and takes 2 measurements. And we get a 1 and a 1. So here's what our robot is seeing. So we moved directly into a corner. Well, we didn't program anything to identify a corner. So when it runs into a corner, it backs up, turns right, turns left, takes 2 measurements. Well, they're the same. Well, what do? It doesn't know which direction. It could even be, we can even be 1.5. So let's say they're different. So obviously this one is a greater distance. But when we go back into this loop, we're automatically under our 2 feet. So what we do is we program a failsafe. If we ever fall in a parameter where our 2 outputs are the same and less than our 2 feet, or they're different but the greater one is less than 2 feet. So let's start off with if they're the same. So we have 1 and 1, but it's still less than 2. We can ask our robot to just shut off. So say, hey, they're the same, but we can't go back into this loop because we're still under 2 feet. Then we'll just shut it off, set off alarm, and us as an operator will go and reset the robot. Or we can just say, choose a side, back up, turn right, and then repeat the process. If we're in a corner, it's eventually going to work its way out. Or let's say that's going to be kind of the same way if one's greater than the other. It's going to choose this side, back up, turn, start the loop, find out we're not within our parameter, and then go through this process. And eventually it's going to work its way out of the corner.
Alright, so we have our program. We know how it works. Lastly, we have to get the program into the robot's control module. So how do we do that? We do that through the user interface. And right here on this Arduino board, right here is the connection to the user interface. So we plug in our USB cord to this port and the other end to our computer. And since some people use Arduino, PyCharm, MATLAB, Visual Studios, or any other type of programming software, each developer has a different process for actually getting these programs loaded into the robots. So my recommendation to you is to look up your software developer's recommended directions for uploading the programs and follow those, and it'll get you right on your way to running that robot.
Alright, so that's going to wrap up this video on programming. If you like this video and you want to see more like it, please consider subscribing and hit that like button to let me know. If there's any other videos you'd like to see about the science and engineering, please put it in the comments below. I'd love to hear from you, and until next time, I'll see you later.